Good morning and welcome to day 3. It's the DATRON Digital Experience Days 2020 and today we have a little helper at our machine. Actually, it's not that little and it's kind of a big helper. It's a robot. So today I'm not alone. I have my colleague Volkmar here, so he's our expert in automation, in any kind of robotics, and we're going to talk about what is needed and what can a DATRON machine provide when it comes to automation. We have the setup here with an M8 Cube, a robot cell on the side, and at the beginning we just have like a demonstration loop running in the background of the machine. So we're going to talk a little bit about the theory, what kind of devices do we need, what kind of hardware and software is needed for automating a DATRON gantry machine. So we have prepared this little overview, and yeah, Volkmar is going to tell us a little bit about all the different components. And in between, we're gonna see them on the machine. As far as we can do.
I also like to welcome to you to our session tomorrow. So in the center of the automation, we have our machine. So this is a base component. You can choose whatever you want on our machine. So for equipping the machine, you have several chances or possibilities to interact with the machine. For example, you have the automatic front door. We can show later on what you can do with that. The automatic front door is allowed to equip the machine with manual handwork, or also you can use it by automatic robot interaction.
So let's just have a quick look at the automatic doors. I just moved that on the side. So this machine is basically equipped with a front door which goes vertically, and a side door. So this robot, this cell is connected with the side door. You probably saw it in the intro. So it reaches in from the left hand side. And if we just demonstrate this front door, I just pause my program and click open door. So it will just move up. So I got this little, this big window to load and unload the machine automatically. So that's actually the hardware side when it comes to loading and unloading the machine. What else is needed?
So another door or another chance, you have the automatic side door. You can see, you saw at the intro in this video, in this session. So this door is not allowed to use by manual. It's just an automatic door for equipping the machine with a robot. You can see actually on the side. So another thing is you have two kind of interfaces. You can see in the bottom of the flip chart. On the left hand side you see the digital user IOs. With the digital user IOs you're allowed to activate the clamping system on the machine. For example, a vacuum thing or a clamping, a manual clamping system. You also see right now here on the machine.
We have an automatic centric Vise in the machine, which is controlled by the IOs, what Volkmar just said. So actually different possible solutions for workpiece holding. So the chuck will automatically open and close.
This is also useful for working without a robot. But the most important thing is for interacting with the robot, this point of view. So it's an automation module. It's an automation box where you have some safety signals to interact with the robot or with an automatic cell, and also some communication interfaces, communication IOs to interact with the robot. So you can tell the robot you're allowed to go inside, you're not allowed to go inside, please open the chuck or close the chuck. And the safety signals are connected with the safety signals of our machine. So if you have some emergency problems with the machines, also the robot will be stopped automatically and vice versa. So this is the second and most important thing. These points you are allowed to program with a normal, simple interface. So you can program it in the steps of your milling program, and you have an additional second running process where you can program the things parallel to the milling process. For example.
So just to get a little summarization of this, we have parallel, like a parallel loop that controls all the safety signals, like a door, like if the chuck is closed,
yes,
if the robot is in its correct position, if the spindle is on, so everything that is important for our entire milling, loading and unloading process. And it's basically checking this permanently and external of the NC code. Yeah, that's a pretty important thing, and I think you mentioned that when we have the library functions for your different like chucks, like you want to open the door, you want to control the robot, you can just set up your own little programs and like macros and just connect them to wherever you need them.
Yes,
right?
You're completely right.
Okay.
So you can set up your own libraries and you can prepare them or modify them as you want it. It's your choice.
Okay, that's very good.
So,
and I think last but not least is about collecting all the data, right?
yes. So the final step or the high level step is the REST API we can offer. So we have two different choices for the REST API. The REST API basic is to collect data from the ERP system, for example. So tool life data, the state of the machine, the running time for a special program, for example. So with this REST API, you can collect the data and you can show it on HTML site or something like that, or as I told you, the ERP system. So the most important thing is the REST API automation. With the REST API automation on top, you can control the machine from a remote PC, for example. So you can start the program, a program on your choice, you can stop the program, you can interrupt the program, and all these things to interact with the machine automatically.
All right, so so much about the theory of everything. So let's have a closer look at the machine and what is happening inside. So yeah, we've loaded the part a couple of times now, and I've just basically interrupted this loop, and we're going to start a milling process once it's loaded the next time. So at the moment, what the machine is doing is a cleaning cycle, a cleaning process. So it's basically blowing off the machine or the machine table from chips. As this is a gantry style machine, you know, the chips will like pile up on the table. So in order to get the process stability, we need to make sure that all the chips are, or like most of the chips are like out of the way and don't interrupt our milling process. You can see that little blow-off nozzle on the left-hand side of the Z-axis. There's this little like flat kind of nozzle. Which cleans the machine table, and what the robot is doing now, it also has a little blow-off nozzle on its handling arm, and it's blowing off the gripping station, the chuck. So we're touching off the part, locating the origin in the center, and then we're gonna make some chips. See how it's loading and unloading. And if we talk about automation, there are a lot of things to consider and to look at. So the handling system, and like in this case, the robot, is just one part of the entire process. So it is about the tooling? Do we have the right tools for this application? Can we make sure that our machine stays clean? That we have, that we can be sure that the machine is running permanently, basically on its own, and that there's no, that the operator does not have to clean the machine, adjust things. So many things to consider and to look at. So again, we get our stepped single flute cutter on the run now. It is doing a pocketing operation here, followed by a brand new tool which we're gonna look at on Friday on the tools session. It's the DATRON cross cutter. So this is a special single flute which basically has different types of flute, and it's like an interrupted flute. So the chips, if we do this dynamic motion, this like adaptive kind of programming and milling, it is not creating those long chips which pile up a lot quicker. But if we get a little closer to it, we can see that the chips are very small. So it's another important factor that keeps the machine like clean, and we're able to blow all the chips off. And if we talk about tools during an automation process, it is, or the software, the DATRON Next software offers more options in terms of sister tool management. So what does that mean? So if I have like an overnight job running and I know that my tool will be probably wearing out after a certain amount of hours or a certain path, we're able to put this tool a couple of times into the machine. So let's say we have this cross cutter like 5 times in our machine. So it's basically the same type, the same tool type, but it will automatically change from tool type number 1 to tool type number 2 once it's worn out. So this is an extremely functional software option, because it will just make sure that we have enough tools to run the job, even if tool wear is something that has to be considered. Furthermore, we can actually connect more or different programs, different parts that we want to do in one setup. So we have this kind of housing which we are currently doing, but we could also do something on the vacuum and just let it run after this housing. So not parallelly, but like one job after another without manually changing the program which is loaded in the machine's software. So we can have multiple programs. We have a program management, we have an origin management, so different 0 points are possible. And what we mentioned before is that all these commands, the commands that come like regularly, like opening an automatic door, like triggering the robot, loading a part, everything of this can be programmed in a library, and this library can then simply be called in just one line, in just one command. So we can now see extremely good how small the chips are. If you know videos that we have online where we do a similar electronic housing, we've been using a different tool there, and the chips, those long chips from the trochoidal cuts, the amount and the volume of the chips that sit on the table is a lot more. So that is really beneficial, and we're gonna look closer into this tool technology on Friday. Don't miss that. It's gonna be the last session of the week on Friday, and it's gonna be very exciting. We'll have different tools. We can have a quick look into the robot cell, just from the outside how it looks. So we got different drawers. We just put our external camera a little closer. So if we just come a little closer, we see there is one drawer which came out where all the raw parts sit and where the robot will handle them. And they're on different stages. So we have, like, in total, it's like about 4 or 5 of these drawers. And it's completely depending on the application that you want to run, like how many parts you can hold at this time. And like once this part is finished, we're gonna take a closer look into the robot cell, so we can see how it's like basically dragging out the drawers and the pallets, and then handling the parts. So we're in the final stages of this milling job now. And like basically the last important thing to look at now is how the machine will clean the table. All right. Now in the final corners of machining. It's doing a tool change now to like basically just an empty collet. So there's no tool that we can get as close as possible to the part, so there is no tool sticking out. And we're going to take a little closer look and see how the chips are blown off the table. So there's like a zigzag movement that's going from the back towards the front of the machine. Blowing off the part again. Let's go into a safety position. And here comes the robot. So this is actually a very nice view of the inside. We're basically going along with the robot as it's pushing in one of the drawers, it's dragging out the next one. And now taking the part from second operation. All right, there we go. Thank you for watching. I think this was a very interesting thing to talk about. We've seen a lot about how the like all the interaction between a robot cell and automation cell and a DATRON machine can work. I want to thank you, Volkmar, for explaining everything of the theory and everything that is needed on a machine. If you do have any questions, there is a chat box in this window. Just let us know any questions or whatever you want to know. Thank you for watching. My name is Mark. Don't miss tomorrow where we'll look at dispensing. Thank you.
Thank you so much.